Hello there, welcome to the June 2019 paper 1. Here we're looking at question 4. Prove that for n existing in the integers where n is greater than or equal to 0, this summation here is equal to this thing at the back here where we've got a, b and c that needs to be worked out. So we're not going to do this by proof by induction, we're going to do it by the series method of differences. So the first thing we need to do then is sort out these partial fractions. So r plus 1, r plus 2 and r plus 3 will now equal a over r plus 1 plus b over r plus 2 plus c over r plus 3. So let's now multiply the whole expression by all three of these brackets here. It's going to give us a times r plus 2, r plus 3, add b lots of r plus 1, r plus 3, and c lots of r plus 1, r plus 2. And now let's start substituting in strategic values of r. Let's start by substituting r equals minus 1. So that's going to give us 1 equals a times 1 times 2. So therefore we now know that a is equal to half. Substituting in r equals minus 2 will give us 1 equals b times minus 1 times 1. So therefore b equals minus 1. And substituting r equals minus 3 in, that's going to give us 1 equals c lots of minus 2 times minus 1, which is going to give us c equals a half. So therefore our summation is now 1 over 2 r plus 1 minus 1 over r plus 2 plus 1 over 2 r plus 3 from r equals 0 to n. Okay, so now that we've got our summation written in partial fractions, we can now start substituting in some values. So when we substitute 0 in, we're going to get 1 over 2 lots of 1 minus 1 over 2 plus 1 over 2 lots of 3. So that's substituting in r equals 0. Then we add that onto 1 over 2 times, now 1's going in now, so it's 1 over 2 times 2 minus 1 over 3 plus 1 over 2 times 4. Then it's going to be plus, so we substitute in r equals 1 there. Then we'll substitute in 2, so 1 over 2 times 3. Then it's going to be minus 1 over 4. Then it's going to be plus 1 over 2 times 5. That's when we substitute in r equals 2. Then we'll substitute in r equals 3. This will be the last one before we go up to the ends. So it's going to be 1 over 2 times 4 minus 1 over 5 plus 1 over 2 times 6. So that's when we substitute in r equals 3. Now let's have a look at how we might, let's do dot 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 dot. Let's substitute in some r equals n minus 2's now. So we're going to get plus 1 over 2 times n minus 2, so that would be n minus 1, minus 1 over n plus 1 over 2 times n plus 1. That's when we substitute in r equals n minus 2. This now substitutes in r equals n minus 1. So that's going to give us plus 1 over 2 lots of n minus 1 over n plus 1 plus 1 over 2n plus 2. Well, hopefully I've got space down the bottom here for substituting in n. That's going to give us 1 over 2 lots of n plus 1 minus 1 over n plus 2, and then plus 1 over 2 lots of n plus 3. Right, so let's have a look now at how we're going to simplify this by method of differences. Now, what we've got to have a look at is this set of fractions where we've got 3 as the factor that's being put in on both of them. This is going to give us a half of a third, this is going to give us half of a third, and then this is going to be subtract a third. So all of these three terms here are going to cancel each other out. The same is going to happen with these terms here. This is a half of a fourth, this is a half of a fourth, and this is minus a fourth. So that's once you've grouped the two either side together, you'll get a fourth, and then you subtract your fourth, which will then cancel out. So this will cancel out with this and this will cancel out with that and that. Let's have a look for some more diagonals down here. This will cancel out with this and this. So that will cancel out. That will cancel out with that, that, and this will cancel out with this, this, and this. So we cancel out in a diagonal 3 terms at a time. All 3 terms cancel each other out. So now what we're left with is a half minus a half, which will just cancel each other out because those two things do cancel each other out. And then we've got a quarter, so it equals a quarter. And then it's going to be plus some stuff down here, plus 1 over 2 n plus 2 minus 1 over n plus 2 plus 1 over 2 brackets n plus 3. Now I can simplify this to these two middle bits for a starter, just to make life easier for ourselves. 1 over 4, it's going to be minus 1 over 2 n plus 2. Because we've got a whole of this minus 1 over n plus 2 here, and then we've only got half of this 1 over n plus 2 here, so it's minus a half of n plus 2, and it's plus 1 over 2 n plus 3. Right, now we need to make common denominators on all this stuff, so it's going to be 1 over, so not 1 over, but on the common denominator, in fact let's just do a big common denominator. Let's do a big common denominator of 4 n plus 2, n plus 3. Right, so on the first term, we already had the 4, we needed an extra n plus 2 and an n plus 3. On the second term, we already had a 2, but we need a 4, so it's going to be 2. We already had the n plus 2, but we do need the n plus 3. And on the third term here, we already had a 2 on the bottom, so we need an extra 2, and then it's also going to be n plus 2. Right, let's expand all of this and simplify. So n squared plus 5n plus 6 minus 2n minus 6, and then it's plus 2n plus 2. So what can we simplify here? It's going to be the 6 and the minus 6, that will cancel each other out. And then we'll just have to simplify it all together. So 4n plus 2, n plus 3. So when we simplify all this down, it's going to be n squared, 5n minus 2n plus 2n. Oh yeah, we can cancel those bits out, so it'll be plus 5n. And then it will be plus 2. Oh no, sorry, it's when you expand the 2 with the 2 here, you get 4 on the back here, so it's plus 4 on the back. So plus 4 over 4n plus 2, n plus 3. And then we factorise to give our final answer of n plus 1 over, so plus times n plus 4 over 4 n plus 2 n plus 3. And there we are, that's the answer for this question here. So A equals 1, B equals 4, and C also equals 4. Apologies for that little mistake there. So there we are, 5 marks for that question there. I don't think that was worth enough marks. I think we should be at least getting 6 or 7 or 8 for that question there. Lots to do there. Question 4, let's move on to question 5.